All right, demo E4. So we're starting with question 1 of 2, and this is what we're calling the parallel wand-maker's dilemma. So we've already talked about the wand-maker's dilemma. This is a sort of a variation on the original. And this was given in a previous semester homework assignment. All right, so we're given a demand curve, which is pretty simple. And we have two main wand sellers, Ollivander and Grigorovich. Ollivander has a marginal cost of 10, and Grigorovich has a constant marginal cost of 5. And we're given no fixed costs, so we just use the constant marginal cost. Okay, and then we have two marginal revenue curves which look symmetric, but this is not a symmetric game because there are two different marginal costs. So this is going to present sort of a more complex environment. All right, so the general outline, we're going to start with two best responses and then solve for Nash equilibrium, quantity and prices. All right, and then we'll do a little bit more. So as always, we solve for the solution to the firm's problem to find the best response. We set marginal cost equal to marginal revenue, MC equal to MR. Marginal cost is 10, and this is our marginal revenue. And then from here, we just solve for Ollivander's quantity. This is how Ollivander picks his quantity. We just set MR equal to MC and then solve for Q0 or QO for Ollivander. Okay. All right, so this is the best response. We can do the same thing for Grigorovich, except here, Grigorovich's marginal cost is just 5. So Ollivander has a higher marginal cost than Grigorovich. So we actually need to write out the math here. I mean, you could possibly eyeball this, but I would not recommend that general approach. Writing the math out is, it's really helpful in almost every scenario. Okay. At least for me, it's helpful in catching my own errors. All right, so we have marginal cost, we have marginal revenue. We set them equal to each other, solve for QG, which gives us the best response for Grigorovich. Okay, so we have two best responses. Question 1C is about finding the equilibrium price and quantity. So to do this, we need to find what Grigorovich should do, knowing what Ollivander is going to do. So we have Grigorovich's best response, and then we just take Ollivander's best response and plug it in for QO. So we're intersecting the two best responses, very similar to what we do in sort of the 2x2 context, using the boxing method. All right, so we plug QO from the best response into Grigorovich's best response function, and then sort of simplify the math here. Once we have this, we can collect QG. So we've collected all of the QG terms on the left-hand side, which leaves us a number on the right-hand side, and then we just solve for QG. So this is our QG star. We take QG and we plug it back into Ollivander's best response function. So we already know what QG is doing, and all we have to do is best respond to it from Ollivander's perspective. So we have QO, which is 45 minus 1/2 times 10 over 3. Sorry, 100 over 3. And then we simplify to find QO star. And you can see here, because their marginal costs are not identical, the solution to their firm's problems will also not be identical. And the direction is what we might have predicted at the beginning that Grigorovich will produce more than Ollivander, because Ollivander has a higher marginal cost. Ollivander has a marginal cost of 10, and Grigorovich has a marginal cost of 5. So just looking at this, one might sort of go into this question expecting Ollivander to make less because his costs are higher. Okay, so we found the two quantities. We add them together to get the market quantity of 185/3. And then we plug this into the price. The demand curve to find the price. Okay, so we found market quantity, we found the two separate quantities, and we found equilibrium price. The last part of question 1 is to impose a tax on wand sales. This was apparently used to make sure only the wealthiest were able to attend wizarding school, deepening the inequality. So we have some sort of outline of how to implement this tax by increasing the marginal cost of production by 10 galleons. Remember, when we were talking explicitly about taxes, we could either model it as a tax wedge, we could model it as a cost increase, so we're adding to the cost side, adding to the firm's supply curve, or we could add it as a decrease in the demand curve. So we subtract some of the benefits from buying. Either way we did it, turned out the math came out to be the same, so the recommendation is to always use the approach that feels simplest. And here, the simplest approach is simply to add to the marginal cost. So we add 10 galleons to the marginal cost, and I've just simplified this using the best responses from above instead of writing everything out again. So these are the two best responses I got. And then to find the equilibrium, we just take Grigorovich's best response, plug in for QO using Ollivander's best response, and then solve for QG. So we simplify this. We have almost all of so we have one QG term on one side and one QG term on the other. We just combine them on the left-hand side, and then we solve for QG explicitly, which is this QG star equal to 30. This game is not symmetric, so we have to directly solve for QO. So we take Ollivander's best response here and plug in 30 in for QG. So we plug in 30 here and then simplify. So we get a QO star of 25. Our market equilibrium quantity would then be 55. And we plug 55 into our demand curve to get a price of 45. All right, so this is an example of an asymmetric duopoly. And we've solved for equilibrium, or for best responses for both players, and then for equilibrium. And then we've imposed a tax on the system. And we've shown what happens to prices and quantities. I haven't explicitly asked for a description of how things changed after the tax, but that's something we can do. Okay, great. So the second part of this demo, the second question, is simply a monopoly, and we're going to impose a policy at the end. Okay, so we have Wizard's Chess, which is a common game played by the wizarding world, but there's this proprietary technology that is kept secret and only sold through the Weasleys' shop from some anonymous seller, which we call X. So we have a demand curve here and a marginal revenue curve and a marginal cost curve that's constant at 1 galleon. And we're explicitly told that there's no fixed costs. All right, so we have a graph. We set up our demand curve, our marginal revenue curve, and our marginal cost curve. And then the way I usually solve this is I first just simply graph the solution to the firm's problem, and then the subsequent questions ask for sort of the process. All right, so we have marginal revenue on, say, the right-hand side, and marginal cost on the left-hand side, and then we solve for Q. So we have our Q star, which is 9/4. So we just plot that on the graph. And then we find the price. So we plug 9/4 into the demand curve and solve for P star. And then we plot this on the graph here. And then we find profit. So we plug price 11/2 into the profit equation, and quantity 9/4 into the profit equation, and that gives us this thing. 81/8 is profit. And we can plot that up here too. So here's our profit. This question doesn't explicitly ask for deadweight loss, but we could include that here. Just the area under the demand curve above the marginal revenue curve inside the social planner solution. Okay. And then the last question here is about subsidizing Wizard's chess. So the idea here is we impose a 1 galleon subsidy on Wizard's chess. And you'll remember marginal revenue was, this should say marginal cost. Marginal cost was originally equal to 1. So when we subsidize, we're essentially taking one galleon away from the marginal cost. Just imagine this said marginal cost. So we're taking 1 away from the marginal cost with the subsidy. So we're bringing this post-subsidy marginal cost to 0. So the intersection of the marginal revenue and marginal cost curves happens right here at the origin of marginal revenue. So this gives us Q star sub, which is greater than it was before the subsidy. So quantity for the monopolist has gone up after the subsidy. And this also has the effect of decreasing prices. We go from P star to P star sub. And graphically, the change in profits isn't exactly clear, whether it's getting bigger or getting smaller, right? We have a decrease in price, which we would think would decrease our profits, but we see an increase in quantity. So these two things we might think would be possibly offsetting, but we don't know exactly the direction, at least initially. But we also have a decrease in the marginal cost. So you can do a little bit of work to show that that profit is actually going up in this case. But intuitively, the reason we would expect it to go up is because if the firm wanted to, they could continue to produce at Q star. They could solve their problem by continuing to produce at Q star. And in that case, they would have increased their profits simply by the subsidy being imposed. So we go from 1 to 0, and that would change our total, or our profit box from this rectangle above marginal cost. It would just increase it by this area down here. Costs have gone down, and that's all that would have changed. But we also know that the firm can improve upon that by solving their problem in a different way. So if they originally were only producing at Q star, when the subsidy goes into place, they can increase from Q star to Q star sub after the subsidy and increase their profits from Q star. So that's kind of the intuition. You could do some work. You could solve for all of these values and show that indeed profit is going up, but this is enough. Okay. Email me with questions as they arise, and I think we'll leave it here.